Hello. In this video, we can have an introduction on system of particles motion and also what is a rigid body. Now, till now, we consider the motion or we studied the motion as point object. Point object. One-dimensional motion or two-dimensional motion, whatever it is, the motion that is studied till now is considering the object to be point-like, so that all the equations and laws can be applicable. But in this chapter, we take distribution of mass, extended mass. What is meant by extended mass? If the mass is distributed in space, we call it as extended mass. For example, if I consider the Earth-Moon system together as a single system, then the mass of Earth and mass of Moon will be considered distributed in space. Or mass distribution of solar system altogether, if we consider, it comes as an extended mass. Therefore, in this chapter, when we discuss the case of mass of the system, that mass m can be equal to m1 plus m2 plus m3 plus etc. It goes like that. So, the case must be considered in the split form, or what you call the sum of all the individual mass particles, you can say. Now the same case is coming in the case of what you call rigid body. Rigid body. What is a rigid body? It's a solid body. Its shape and the size is not changing by the application of the force. Such a solid body is called a rigid body. So if I take a rigid body, suppose this is a rigid body here. This rigid body can be considered as made up of minute mass particles like this, n number of mass particles. So when we say the mass of the particle here, for the rigid body, that can be taken as sum of m1, m2 and etc. up to mn. So when we consider the rigid body like this, there can be force of interaction between the two masses here. And like that, two masses. Like this, any two mass particles inside the rigid body will be attracting each other. The force, we call it as internal force of attraction. And this internal force of attraction is always cancelled because they are equal and opposite. So when we consider the whole rigid body or an extended body system, the internal force will be zero as they are cancelling each other, or as they are mutually applied on each other. So internal force of the rigid body system is always zero. Okay. So when we consider the motion of rigid bodies, we can have, suppose the motion when we consider for the rigid body, let us say, suppose this is the rigid body and mass particle m1, m2, m3, mn are there, n number of mass particles. And when I apply force F on this one externally, we can find that the whole body will be moving. And as the whole body moves, you cannot say the body is in translatory motion or what you call rectilinear motion. No, you cannot say that. Because when the force F is applied and the whole body moves, the rigid body moves, each mass particles will be moving in a line of its own as the whole body moves. So whether you consider the case of this rigid body moving around, for example, see, rigid body, same rigid body if you take, and if it is moving around like this, if the rigid body is moving, going around this one, right, the mass particle M1 and M2, M3 like that, if you consider, the mass particles will be going around this axis in its own circular path. But when we consider the whole body, we cannot say that the whole body is moving in a circular path. No. Rigid body is now just rotating about this fixed axis, we can say. So when we study the motion of rigid bodies, we have to consider the mass particles motion individually, and when we apply the Newton's equations and all that, you will be writing equations in solving all these problems. It is very difficult. So to reduce this problem, we introduce a concept called center of mass. Center of mass of the mass particles. Now, what is the center of mass? Center of mass of the rigid body we can consider like this, that as the whole body moves, the effect of all these mass particle motions can be concentrated at a particular point of the body, and this point moves with a speed that is equal to the speed of the body if the force F is applied directly onto this point. Okay? Or in another way, we can define this as the point where the whole mass of the body is supposed to be concentrated. I think that is the better way to take it. It is the point where the whole mass of the body is supposed to be concentrated. Such a point is called the center of mass of the body. So, if you consider such a point here, instead of writing all that n equations, you can write a single equation for the motion of the center of mass itself to understand the whole motion of the body. So that the problem is reduced. So, center of mass is the point where the whole mass of the body is assumed to be concentrated. So, center of mass is the point. It is a point only, okay, where the effect of whole mass is appearing to be acting from, you can say. Okay. So, to understand more about this center of mass, let us consider the case of a sphere. A solid sphere, when we consider a solid sphere, if I am considering, you can have the whole mass effect acting as if concentrated at its center. Alright? Or if you take a long road, you can have the balancing of this possible at a particular point only. It can be balanced. And that balancing point will be actually near to what you call the center of mass of the body. Alright? So, you can draw and find out the center of mass if the mass distribution is what you call a structured weight. For example, if the mass is distributed like this, for example, 4 masses, extended masses system you can see, then you can have the center of mass of the system seen like this, at this particular point. So like this, each and every mass distributions will be having its own center of mass, and motion of that center of mass you can analyze so that you can have the motion of the whole